Alright, today we're going to learn to solve two-step equations using tape diagrams. These are going to help us figure out the different operations in our equations since there's now more than one operation occurring. For the tape diagrams, we're going to start off with our equation of 3x plus 2 equals 20. And we need to talk a little bit about what a tape diagram is. A tape diagram helps us visualize these equations using a part-whole method. So looking at this equation on the left side, we have one part is 3x, and that's being added to another part that's equal to 2. And all together, that part plus the part equals a whole of 20. So to draw this out, we're going to draw our piece of tape here. And we have 3 x's, which means we have 3 unknowns. And we're trying to solve for the value of that unknown. So we're just going to draw in the 3 unknowns right now and label each part as x. So we have 3 x's. And then with that, we're also adding that to 2. So this last part here, we're going to give a value of 2. Now this whole piece of tape is equal to a value of 20. So what we need to ask ourselves is, we need to figure out what the unknowns are equal to. So first let's just look at all of the unknowns together. If we're going to add this part plus this part together, it needs to equal 20. And that means that this part all together, these 3 x's, are going to have to equal 18 because 18 plus 2 equals 20. But we ultimately want to figure out what one x is worth. So now we're looking at how many x's we have and dividing that between this number here. So we have 18 right now, and we're dividing that between 3 different parts, which means in this case x is going to equal 6 because 18 divided by 3 equals 6. And we can check that answer by plugging it back in. We have 3 times 6 is 18 plus 2 more equals 20. So that was just our first example here. Now let's see what happens when we have one where we have some subtraction. So now we have the equation 4x minus 3 equals 9. So we're going to draw this out in a tape diagram, very similar. So we're going to start with our piece of tape. Now we have 4 unknowns, or 4 x's. So here are our 4 x's. And then instead of adding 3, we have a negative 3 or a minus 3. So we're going to put in a minus 3. And this whole tape has a value of 9. So now when I'm looking at these 4 x's this time and saying this number, this unknown, minus 3 has to equal 9. Well, what minus 3 is going to equal 9? Well, that would be 12. 12 minus 3 is equal to 9. And now I'm thinking about, well, now what is 1x worth? Well, I have 4 different x's, and altogether they're worth 12. So if I split this evenly, that means that x would equal 3 because 12 divided by 4 is equal to 3. And again, we can check our answer by plugging it back in. 4 times 3 is 12, minus 3 is equal to 9. So we know that x equals 3. Alright, that's great, but what happens if we have negative x values? Well, let's test it out. If we have negative 2x plus 4 equals 8, we can still represent this using a tape diagram. So again, we have 2 unknowns, but this time the unknowns are negative. So when we draw in our x's, I'm going to label them as negative x's. So that's one part of the equation. The other part is adding a 4. So we're going to put our 4, and all together this time it equals 8. Well, now I'm still looking at the same thing here. If I want 4 plus this unknown part to equal 8, that means that this part is going to have to equal 4. So I'm trying to split 4 evenly between these 2 x's. And if I do that, it means that there's 2 that go to each spot. Now I'm moving positives, but I'm moving them into a negative group, which means that x is going to equal negative 2. So now if I check, if I take negative 2 times negative 2, that equals a positive 4, plus 4 is going to equal 8. So this works once again. But one thing to be careful about is if we would have the same equation except we would end with a negative 8 over here. That means now we need to think about this being a negative 8. So now when I go to think about what this x needs to be, I'm thinking about 4 plus what is going to get me to a negative 8. Well, in order to get to negative 8 with a 4, I would need to add a negative 12 or subtract 12. This is the part that we have to be careful about, because now if I'm moving negatives into these groups, I'm going to move 6 into each group, but I'm moving negatives into negative groups, and the double negatives are going to cancel out and create positives. So now I would have x would equal 6. And if I check that equation, that since I've changed this to a negative 8, I have negative 2 times 6 is negative 12 plus 4 is negative 8. Okay, so if you're moving negatives into negative groups, remember your answer is going to be positive. If you're moving positives into negative groups, your answer is going to be negative.